So now we are going to see a simple example of the Green theorems applied to this kind of exercises. So now we are willing to evaluate this vector function f over the closed curve that is represented by this equation, and this is actually a circle of radius 1/2. So we know that we have a sphere, sorry, not a sphere, a circle that it has a radius of 1/2. Thus, we know that this integral, because it is a closed bounded region that we are evaluating, can be made as this by the Green's theorem: double integral of the region of partial derivative of f2 with respect of x minus f1 dy dx dy. Okay, so we can get the partial derivative of f2 with respect of x, and we know that f2 is equal to minus x, hence the derivative will be minus 1, and the derivative of f1 with respect of y will be this y derivative with respect to, derivative with respect to y will be equal to 1. Then the integral will be transformed to this minus 1 minus 1 times dx dy. This will be equal to minus 2 and the integral of dx dy. However, from the previous part of the videos, we know that this integral is equal to the area of the closed bound region, and that the area can be also equal to 1/2 of the line closed curve integral of x dj minus y dx. But it can also be evaluated in polar scale as the radius squared d theta. And we know that the radius is equal to 1/2. Hence, the area can be evaluated as 1/2 of the closed boundary region. But we know that as it is a circle, the angle theta will go from 0 to 2 pi of the region, the radius squared. So you know the radius is 1/2, but square is going to be 1/4 of d theta. Hence the area will be 1/8 of theta evaluated from 0 to 2 pi. This will be equal to 2 pi over 8 minus 0 over 8. This also will be equal to pi over 4. Is that right? I guess it is right. Hence, the result of all this will be equal to, going back from here, minus 2 times the area that is equal to pi over 4. And this will be equal to minus pi, checking in Spanish, over 2. And there it is, an example of how to use Green's theorem to evaluate a function in a closed bound region.